Welcome everybody to expected value. So, expected value. Have you ever gone to the carnival at the 4th of July at Delano, and have you ever played that game where you get like a bucket of those red rings and you're trying to throw them and make them land on the top of the pop bottles? And then if you get like one ring on, you get a huge prize because it's really hard to do. Have you ever wondered how fair those carnival games are? Like if you actually have a chance of winning, or are they totally unfair in favor of the carny? We're going to talk about that today. So that's basically what expected value is. What we're trying to do is we're going to try to figure out, let's say you played that ring toss game 200 times, what would be your expected payout? And just so you know, the game is fair if your expected payout is equal to $0. So if your expected payout is $0, the game is fair to both of you. If your expected payout is negative, it's in favor of the carny. And if your expected payout is positive, it's in favor of you. And when I say expected payout, that's what expected value is. So here's how I find expected value. I'm actually going to rewrite it up here because we have more space this way. To find expected value, basically we're going to multiply the probability of getting something and then multiply that by the payoff amount. So I'm going to say the probability of event 1, so remember P means probability, times x1 plus the probability of event 2 times x2 plus ... And just so you know, x1 and x2 are payoff amounts. So if you played this game, let's say you won the game, how much would you win? And there's more than one thing because there's a certain probability of you losing and a certain probability of you winning. And so if you lose, you have a certain payoff amount, and if you win the game, you have a different payoff amount. You need to know that the game is fair if the expected value equals 0. So that means that it's fair in that neither person has an advantage. So you don't have an advantage and the carny doesn't have an advantage. It's equal. And expected value is if you played the game many, many times, what would your earnings be over time? Now, this is really best if I just show you a few examples. So what we're going to do is just do 3 or 4 examples, and then we'll work more on it in class tomorrow. So here's my first example. You're playing a game, you're betting with dice. Don't tell anybody, but we're using a gambling example. Okay, let's say you're rolling. You're actually going to roll a one die, okay? I know I said dice, but we're actually going to do 1 die. If you get a 5, you're going to win $6. If you get anything else, you're just going to lose the dollar that you paid. And there's 2 different examples here. So we'll look at the first row to start off with here. Okay, so you have to figure out what the probability of getting a 5 is. And if I have a single dice, there's 1 5 on the dice, so you got a 1 out of 6 chance of getting a 5. And you have a 5 out of 6 chance of getting anything else. So here's how we apply this to the formula I just told you. In this situation, I only have 2 events that could happen. Either I could win or I could lose. So my probabilities are 1 6 and 5 6. And I'm going to leave some space because I need to multiply it by this other part here, the x1 and the x2. So sometimes there's more than one event that can happen, so we've got more probabilities. But this time it's just win or lose. And we always want to say the actual amount that you win. So even though you get $6, you paid $1 to play, so the payoff amount is actually only $5. And that is what I mean by the payoff amount. So this x1 and x2, that's how much you earn. So if I win, I got a 1 out of 6 chance of winning, and I win $5. I got a 5 out of 6 chance of losing, and if I lose, I am out $1. So -1. So the payoff amount there is -$1. If you multiply those together, you get 5 6 plus -5 6, which is 0. So that is a fair game. And I did the same example, just kind of with more money. So this time you're really, really going big, and you're going to pay $200 to play this game. If you win, you get $1,200. So what's the payoff amount would be the question. So remember, the payoff amount is actually how much profit you made. So you paid $200, you get $1,200, but your profit is $1,000 then. And if you get anything else, you're just going to lose your $200. So the payoff there is negative $200 then. All right, so for this one, you got a 1 out of 6 chance of getting $1,000, and you've got a 5 out of 6 chance of getting negative 200. That one actually ends up also being 0, so it's still a fair game. Right now, if you should pause the video and write down questions you have so we can talk about this tomorrow, because I realize this might be a little confusing the first time you're seeing this. We're going to do an insurance example next. What do you think? Do you think insurance is usually a fair game, or do you think it's unfair in favor of the insurance company? It's usually unfair, but let me show you this. So I'm going to buy a homeowner's policy for my house. It costs $200. If the house burns down, I'm going to be given $100,000. So actually the payoff, the total profit is $99,800. If my house doesn't burn down, yay, all I did was lose my $200, but I didn't lose my house. You have a 1 out of 20,000 chance of it burning down and a 19,999 chance of it not burning down out of 20,000. So remember, you always do probability times payoff plus probability times payoff plus probability times payoff. This one, again, there's only 2 situations. Either it burns down or it doesn't. So I got my probability times my payoff plus my probability times my payoff. And the payoff here is $99,800, and the payoff here is negative $200. All right, so let's type it up to see what we got. So I got 1 over 20,000 times 99,800 plus 19,999 divided by 20,000 times negative 200. Okay, so the expected value or the expected payoff for you is negative $195. So this is an unfair game, and it's in favor of the insurance company. Surprise, surprise. Now here's the deal. For something like your house, you should definitely still buy the insurance because the cost of it is so high if you lose it. But if you have something like, have you ever been to Best Buy and every single thing you buy, even like CDs and DVDs, they ask you, do you want our care protection plan? Do you want our care protection plan? And even if it's like a $40 MP3 player, which is normally what I buy, they say, do you need a protection plan? Usually those things, if you're buying a very small item, it's a waste of money because the payoff amount is not worth the cost you paid. And we're going to get into that more in a little bit. Let's just do 1 or 2 more examples here. Actually, I'll do 3 more examples before we'll end this video. So sometimes they're going to make it boring, and they're going to just give you what you need to know. And the 2 examples I did so far, each only had 2 different situations, either win or lose. Now I just have more. So you still do probability times payoff plus probability times payoff plus probability times payoff, but I'm just going to keep going here. So I've got more than one probability basically. If they just give you information like this, that's it. It's that easy. And you actually end up getting $2.99 for that. So that one would be an unfair game in favor of someone. We don't know what the situation was though. Okay, number 2, and so I just want to point out, sometimes it's easy like this where they just give you everything. Sometimes we have to actually think about it. We're actually going to have to find probabilities, which really isn't that much harder, but you really have to think about it for a little bit. Anyways, an integer 1 through 9 is chosen randomly. The number 7 pays 5 points, the number 3 pays 2 points, and any other number loses a point. What is the expected value? Okay, so remember, we need probabilities to do this. I'm going to use integers 1 through 9. So there's 9 options I could do. Only one of those are 7. So there's a 1 out of 9 chance of me getting a 7. There's a 1 out of 9 chance of me getting a 3. And then there's 7 numbers that are not 7 or 3. So there's 7 out of 9 chance I get anything else. Now it just told me the number 7 pays 5 points. So there I go. The number 3 pays 2 points. Any other number loses a point. So what we had to do with this problem is we made our own little chart. The chart is just like what they gave us here, but we made it ourselves. And to find the expected value, still do probability times payoff plus probability times payoff plus probability times payoff. And you end up getting 0. So this is a fair game. When you're ready, flip to the back. Feel free to pause and write stuff down if you need to. What's happening next is you and a friend are flipping a coin 3 times. If you get 1 or 2 tails, you score 3 points, and your friend loses 3. Any other result gives your friend 1 point, and you lose a point. Okay, so here's what we got to figure out. We got to figure out a probability, and we got to figure out what's the probability of getting 1 or 2 tails. For some situations like this, it's easiest for us to just write out the options to figure this out, because you might not know off the top of your head how many ways I can flip 3 coins. So I've got 3 coins. I could flip tails, tails, tails. I could flip tails, heads, tails. I could flip tails, tails, heads. I could flip heads, tails, tails. I could flip heads, heads, tails. Heads, tails, heads, tails, heads, heads, or heads, heads, heads. So there's actually 8 options. So we want to figure out from your point of view if you get 1 or 2 tails. So 1 or 2. There's 6 of them. So 6 out of the 8 are 1 or 2 tails. It says if that happens, you score 3 points. Okay, so your payoff is 3 points if you get that. Now, there's 2 options we didn't use yet. Those are the 2 that have 0 or 3 tails. So you've got a 2 out of 8 or 1/4 chance of any other result, you lose a point. So you've got a 1/4 chance of losing -1. Now this isn't laid out very well, but we want to find the expected value. It's listed right here instead of down below. So expected value, we abbreviate that EV. So I'm going to do probability times payoff plus probability times payoff. And I actually end up getting 9/4 plus -1/4, and if you add those together, it's 2. So from your point of view, your expected value is 2 points. So this is actually unfair in your favor. But let's find out what it's like from your friend's point of view. Okay, so from your friend's point of view, if you flip 1 or 2 tails, you're flipping it, but your friend is losing 3 points if that happens. If you flip 0 or 3 tails, your friend is gaining 1 point. So this doesn't seem fair, but we'll figure this out. So probability times payoff plus probability times payoff, and you end up getting -2. So your friend's expected value is -2, and this is not a fair game. It's in your favor. That's all we're going to do on the video. If you want to, you can write down some questions to ask me in class, and we're going to practice this more because there's a few different situations that I haven't talked about yet, but it's best if we do them together. So thanks for listening, and hope you have a great night.